Good morning, Year 6, and welcome to Tuesday, the 2nd of February's maths lesson. So today we are continuing to build on to understand algebra more. And yesterday we looked at one-step functions, and today we are looking at two-step functions. Okay then, so let's warm our brains up today and let's see whether you can find the missing function for the first question and then the missing input and output for the second question. So pause this video here now and have a go at those two questions. Okay then, so for the number 1, you should have found out that the missing function is divided by 4. So 36 is our input, divided by 4 is our function, and 9 would be our output. That works as the same with 100 as our input, divided by 4 as our function, and then 25 as our output. So then for question 2, you had to calculate the missing input and then the two missing outputs. So we know our function is subtract 8. So 127 subtract 8 is going to give us 119. 10 subtract 8 is going to give us 2. And then minus 1 subtract 8 is going to give us minus 9. Okay, there are our vocabulary for this week that we are still working through. So let's have a look at today then. So you can see already that instead of just one step, we have got 2 steps. So let's start off then. It's a different way of writing rules by using an input machine, so a function machine. So 3 goes in, we multiply by 2, so that's going to give me 6. And then we add 1, which is going to give me 7, which is going to become my output. So the answer would be 7. Let's do the next one. So 10 goes in, we multiply by 2, which gives me 20. We add 1, which gives me 21. Okay, then I want you to pause this video here and have a go at the 51. So 50 goes in, you multiply by 2, what do you get? You add 1 onto that. What is your output? You should have got 101. Now, for this last one, we haven't got the input, but we have got everything else. So we need to go backwards. So we start off with 11, and instead of adding 1, we need to do the inverse. So we subtract 1, which it gives us 10. And then instead of timesing by 2, we need to divide by 2. So we have got 11 subtract 1, which is 10. 10 divided by 2, which is 5. And we can just check that that works. 5 times 2 equals 10, and 10 add 1 equals 11. Okay then, so let's move on to this one here. We have got the functions and we are missing the input and output. And this dude here says, I wonder if it makes a difference which order the functions are in. So let's try with 2, for example. So let's put 2 in. 2 times 2 gives me 4. 4 add 1 gives me 5. So let's see then if it makes a difference. Keeping our input the same. 2 add 1 equals 3. 3 times 2 equals 6. So it does make a difference in which order the functions are in. Because if you add 1 for the second part, you get a smaller answer. Whereas if you are adding for the first function, you get a bigger answer. Interesting. Okay then, here we've got a true or false. These function machines will give the same output if the input is the same. So let's try then. Let's do 2 again, nice and simple. So let's do the first one. So 2 times 4 gives me 8. 8 times 6 gives me 48. 48. Okay, so let's see whether if we do this time. So if I still put the same input, 2 times 2 is 4. 4 times 12 equals 48. Interesting. Now, why do you think that they give the same output? Well, I know that 4 times 6 is 24. And 2 times 12 is also 24. So your two functions, you're multiplying by 24 each time. So of course you're going to get the same answer. Very good. So that one would be true. Okay then, let's have a look at this question before you get on to some work today. Eva is ordering some crayons online. She needs to buy 22 crayons altogether. How much will it cost for 22 crayons including delivery? So each crayon is 30p each and it costs £1.60 to deliver. Create a function machine to help you. So in my input, I'm going to have 22 and then I'm going to draw, hopefully, a small arrow. And then my first step is that I need to multiply by 30. Now I'm multiplying by 30p, so I need to multiply by 0.30, which is fine because you can do 22 multiplied by 3, which gives us 66. And then you can do 22 multiplied by 0.3, which gives us 6.6. Let's just move that up a bit. There we go. Okay then, so our next steps, can I see whether I can copy and paste that? Yes, I can. So our next step then is we then need to add on £1.60. If I can find my pound sign, there we go, £1.60 for delivery. And then I need to get my output. So we know that we've got £6.60 for our first step. We then need to add on £1.60 to £6.60, which is going to give our output of £8.20. There we go. So that's your function machine to help you answer those questions. So always use the information that you are given. Okay then, so your work today is to complete the two-step questions. So you have got 2 steps that you need to complete. Remember, if you are going from the output to the input, you need to do the inverse. So you need to do the opposite. Okay, so you have got 7 questions on there to have a go at. Have a go at those questions for me, please, and then come back when you are ready to do problem solving and reasoning. Okay then, so problem solving and reasoning, still looking at two-step function machines. So this one here says true or false, explain your answer. Suggest what the functions could be. I think that the function is times 2 and then add 3, because 3 times 2, then add 3 equals 9. So 3 times 2 is 6, add 3 equals 9. Yep, that works. But does it work for this 15? 15 times 2 would be 30. 30 add 3 would be 33, and we've got 13. So that can't be true, so that's false. Okay then, so let's think what it could be then. I think it could be, let's try a division maybe. So divide by 3. So 3 divided by 3 is going to give me 1. 1 add 8 will give me 9. So let's see whether that works for 15. 15 divided by 3. 3, 6, 9, 12, 15 gives me 5. 5 add 8. 8, 9, 10, 11, 12, 13. Excellent. So that is the correct function machine that it could be there. I wonder if you can think of any other different functions that it could be for both of those inputs and outputs. Okay, let's move on to Jackson's question then. So Jackson is using this function machine. So we put times 5, subtract 10. He puts an input into the function machine to generate an output. He then puts that output into the machine as an input. He now has the output of 40. What was Jackson's original number? So he puts the number through the machine once, and then he puts the output back in the input and it comes out with 40. So let's go backwards. So 40 subtract 10 is going to give me 30. 30 divided by 5 is going to give me 6. So then let's see whether we can go back again. So that was the first time. So 6 subtract 10 is going to give me minus 4 times 5. That doesn't work. Oh, okay. Let's see whether we can think of a number then. So let's try 4. 4 times 5 is 20. 20 subtract 10 is going to give me 10. I'm going to put that back in the machine. 10 times 5 is 50. 50 subtract 10 equals 40. So Jackson's original number is 4. So quite tricky that one is there. Okay, so your problem solving and reasoning work today is all here. So bronze questions 1, 2 and 3, silver questions 4, 5 and 6, and gold questions 7, 8 and 9. Don't forget to send in your work to your teachers, and we look forward to seeing all of you on your live lesson today. Bye.